Hello, everyone. This is my pleasure to present our work on interleaved online testing in large-scale systems. This is a work done in Amazon Search. So in this presentation, I will cover three main topics. First, I will briefly introduce the concept of interleaving and how to use that to rank online ranking systems. Secondly, I will introduce how we approach the problem of comparing multi-ranking systems online in practice with interleaving. And finally, I will address a few issues we encountered when we try to build a connection between interleaving and standard A/B tests. So the basic idea of interleaving is actually very straightforward. In standard A/B testing setting, to compare two ranking systems, basically we show those two different ranked lists to two groups of users and collect the users' feedback and determine whether determine users' preference over those two lists. And in interleaving, we do a different thing. We try to interleave those two different lists into one single list where we just collect items from those two lists iteratively and keep the orders they are in their original list. And then we just present this large interleaved list to all the users. And if a user click on one item from list A, we will attribute this action, the credit of it, to ranker A. And in this way, the difference of the credit will represent the user's preference over those two lists. And the good thing about interleaving is that we measure this preference for a single user instead of two groups of different users. And in this way, we reduce the variance of the measurement, and this will translate to an increase of statistical power. And in online experiments, we observed that interleaving can improve statistical power by a huge margin compared to standard A/B tests. So in the three plots, those are just ranker pairs we compared in online experiments in both interleaving and standard A/B setting. And the x-axis are the sample sizes in log scale, and the y-axis are the statistical power. And you can see that interleaving can achieve the same level of statistical power, but with much smaller sample sizes. And because in real application, the online traffic is always a very secret resource. By using interleaving, it allows us to experiment a much higher volume of ideas online. Although interleaving is a very powerful tool for measuring user preference, it also has caveats. So one caveat is that interleaving can only make pairwise comparison. That means if you have, for example, 10 different ranking systems you want to compare online, if you want to really measure all the possible difference, you need to configure all the possible pairwise comparison. That is 45 different treatments in your experiment. But in A/B, you only need 10 treatments. And it is more challenging to actually consolidate those 45 measurements into the comparison of those 10 rankers. Supposedly, we want to have some kind of transitivity that can help us reduce the complexity of the task. And in practice, we observe this weak transitivity property. That is for any three different ranking systems ABC. If we measure that A is greater than B and B is greater than C, then it must be true that A is greater than C. A/B setting, you can actually prove that this is true in theory, but for interleaving, it is much more difficult to actually prove that. But in practice, we barely see a violation of this property. So we basically, based on this property, we develop an approach to compare multiple ranking systems. The idea is that we create a node to represent each ranking system, and if two ranking systems have a statistically significant difference, we draw a directed edge between those two nodes. And in this way, essentially, we can get a graph like this where we present the relationships between all the ranking systems. So in this graph, we can not only demonstrate if a ranker is better than other rankers, but we can also group all the rankers that are not distinguishable within our online experiment. Now let's move to treatment effect mapping. If the previous graph is about the qualitative comparison between different ranking systems, treatment effect mapping is more about the quantitative relationship between rankers. One caveat of interleaving is that we use the difference of credit to measure users' preference over two ranking lists. but this credits cannot be directly translated to the treatment effect we usually measure in an A/B setting. But in practice, for example, for business decisions, we want to use business metrics to make decisions, and those credits in interleaving cannot be directly used for that purpose. So we need to establish a mapping from the credit in interleaving to the treatment effect we use in A/B test. And luckily, the literature has already discovered that there's a strong linear correlation between the treatment effect of A/B test and the interleaving uh, measurement, so that we can actually use a linear model to learn this mapping. And in practice, we use a weighted least square model to measure because we use online data to estimate this mapping, and the online data are all collected with uncertainty, and we want to weigh more on the data point where we have more certainty on it. So basically, the weights for each data point are proportional to the inverse of the variance of these A/B measurements. And in this way, we just put more weights on more certain measurements. After we learn this coefficient beta for any new measurement with interleaving, we can just apply this mapping to obtain an estimated treatment effect that is comparable to the standard measurement we observe in A/B test. And the good thing is that we can also have uncertainty on this estimated treatment effect. Uh, and the reason this is useful is because often we need to run a follow-up A/B test after we find a promising candidate in an interleaving experiment. And this uncertainty of the measurement can help us understand how much traffic we actually need to run the experiment to actually observe significant results of this ranking system. And here are two plots of the treatment effect mapping, and you can see that the linear correlation is very significant. And with uncertainty, basically almost all of the observations have their error bars cross the regression line, meaning that we have this linearity is an accurate picture of the relationship between interleaving and A/B test when we consider uncertainty. Well, treatment effect mapping is a powerful tool for measure the quantitative relationship between ranking systems. It has this corner case that it cannot handle sign flips between A/B and interleaving. So because we are using a linear mapping, if the sign of the interleaving measurement and A/B measurement are different, you're just making a wrong prediction. So in practice, it is very crucial to monitor the frequency of disagreement of signs of your A/B experiment and interleaving experiments. But you can also not expect the signs of A/B and the interleaving to be perfectly assigned because, again, everything is measured with uncertainty. But we can actually calculate the probability of the sign disagreement. So assume both A/B and interleaving are just measuring the same effect. You can calculate the probability of the sign of the treatment effect that are different from the true effect, mu. Then the probability of sign disagreement between A/B and interleaving are just the probability that either one of them are different from the true treatment effect. In practice, with this probability, you can know that how certain you are with the sign of your treatment effect measured in your experiments. And if you have a large collection of measurements, a pair of ranking systems you measured in both interleaving and A/B test, you can actually collect this data and create a dashboard where you monitor the sign disagreement probability. So the dash line is the expected like number of sign disagreement, and the blue lines are the observed frequency of the sign disagreement, and you can see that the alignment of those two lines basically indicate that uh, although we observe some sign disagreements between A/B and interleaving, we understand that this frequency is totally understandable based on for example, lack of power in A/B or interleaving experiments. As a summary, in this presentation, we introduced a few challenges we faced when we try to apply interleaving technique to real production uh, online ranking system experiments. And we also proposed a few solutions to those problems, and hopefully those are useful to the audience. Thank you.